India has done it. It has become now the fourth country to land a spacecraft on the moon after the U.S. and China and the former Soviet Union.
Chandrayaan-3's successful lunar landing was already historic, but it soon revealed something surprising. On August 26, 2023, ILSA, India's moonquake detecting instrument aboard the Vikram lander, recorded an unusual movement on the moon. The seismic readings confirmed activity that wasn't human-made, leaving scientists intrigued. Could it have been a moonquake, hidden tectonic shifts beneath the lunar surface, or perhaps something even more mysterious? This unexpected detection has sparked curiosity and opened new questions about the moon's secrets still waiting to be uncovered. The moment it all changed. 4 weeks after Chandrayaan-3 landed, operations ran smoothly. The Vikram lander and Pragyan rover quietly explored the rocky plains, sending back images of jagged ridges and powder-fine regolith. Then came August 26, when the lander's seismic instrument, the Instrument for Lunar Seismic Activity or ILSA, recorded something entirely out of the ordinary. At first, it seemed like a routine tremor. The moon is not geologically dead, and moonquakes have been documented by Apollo missions decades ago. But this was different. The pattern of vibrations was sharp, sudden, and followed by a faint, rhythmic oscillation, like something heavy shifting its weight in the dust. Scientists at ISRO expected to find a clear geological explanation, perhaps a microimpact from a small meteorite or thermal stress fracturing beneath the surface. Instead, the tremor's signature looked almost mechanical. It had a repetitive cadence that natural events rarely produce. The signal lasted for a few seconds, faded, then returned minutes later, stronger. No camera captured the source directly, but Vikram's logs show subtle changes in shadow lines on the horizon during that period, as if something had moved and then stopped. Engineers debated whether it could have been the rover itself, but Pragyan's location and systems showed it was parked and inactive at the time. So if it was not the rover, and it was not geological, what was it? That was the question that began to haunt the mission logs, and the moment Chandrayaan-3's story shifted from routine exploration to unsolved mystery. Could it have been debris from past missions, dislodged by temperature shifts? Or could it have been a buried rock breaking free? Or could it have been something else entirely, something unrecorded in any moon atlas? If this was just the first hint, the real story might still be buried under the regolith. The moonquake that wasn't. When scientists use the term moonquake, they are usually describing one of 4 types: deep quakes from tidal forces, shallow quakes from tectonic activity, quakes caused by meteor impacts, and thermal quakes from temperature swings. But the ILSA data from Chandrayaan-3 did not fit neatly into any of those categories. The waveforms were too precise, too abrupt, and too localized. It was as if the source of the vibration had a beginning and an end dictated by an external force, rather than the slow decay of natural energy release. In the hours after the anomaly, engineers tried to replicate the pattern in lab simulations, feeding it through models of lunar rock density, subsurface layering, and seismic propagation. The match came back closer to the vibrations you would expect from a moving object of significant mass making intermittent contact with the ground. That meant, theoretically, it could have been caused by something dragging, hopping, or shifting across the surface. ISO publicly released the data, framing it as an unexplained seismic event rather than hinting at anything unusual. But privately, teams began reviewing past mission records. Apollo's seismometers had recorded strange shallow moonquakes in the 1970s, some of which lasted over 10 minutes without a known cause. Those, too, had generated speculation about subsurface movement. Could Chandrayaan-3's detection be a smaller-scale version of something ongoing beneath the lunar crust? Or had the mission simply been in the right place at the right time to catch something passing nearby? There were whispers, too, of older Soviet lunar missions having picked up mobile anomalies in seismic records, though no official confirmation exists. If that is true, then perhaps this event is not unique, just the first time it has been observed up close in the Moon's southern polar region. And if something is moving there, is it alive, is it mechanical, or is it something else entirely, something no human category yet describes? Shadows in the polar light. The southern polar region of the Moon is one of the most intriguing places in the solar system. Permanently shadowed craters hold ice that has likely been untouched for billions of years. These shadows are pitch black and cold enough to trap not just water, but possibly other frozen materials. The region where Chandrayaan-3 landed lies near one such shadow zone, and in the days surrounding the seismic anomaly, the lander's horizon images recorded something peculiar. In a sequence of frames taken before, during, and after the tremor, a small dark shape appears near the ridgeline in the distance. It is not a dust plume, because its outline is too defined. It is not a lens artifact, because it shifts position between frames in a way consistent with an object moving relative to the lander. The resolution is not high enough to determine its nature, but analysts noted its apparent upright profile. Naturally, there are mundane possibilities. It could have been a rock revealed by subtle changes in sunlight, or a trick of shadow and contrast. But paired with the seismic data, it becomes harder to dismiss outright. When geologists study planetary surfaces, they often rely on multiple data points. If seismic and optical anomalies occur at the same time, the odds of correlation increase dramatically. Some have speculated that the object could be an errant piece of descent debris, shifting under temperature changes. Others imagine a chunk of ice breaking free from shadow and sliding downslope. But in the more speculative corners of lunar research, there are those who wonder if the Moon's pole hides something that occasionally stirs, perhaps ancient hardware from an unrecorded mission, perhaps even something that predates human exploration entirely. The southern pole's shadows have hidden their secrets for eons. Now, for the first time, something within them may have moved. The instruments that listen in the dark. ILSA, the Instrument for Lunar Seismic Activity, was never designed to capture headlines. It is a compact, MEMS-based sensor mounted on the Vikram lander, built to listen for the faintest tremors in the lunar surface. Its job was straightforward: measure natural seismicity, log meteorite impacts, and help scientists understand the mechanical properties of lunar regolith. But in the silence of the Moon, even small anomalies become impossible to ignore. The August 26th event did not just show up as a blip, it produced a waveform that repeated in a suspiciously structured way, as if the source had a rhythm. This intrigued engineers because the Moon is a place where seismic energy usually disperses quickly, leaving behind irregular, fading signatures. A pattern signal is rare, and when it does appear, it often points to either human activity or a highly specific physical process. Since there were no astronauts, and the rover was confirmed stationary, the team had to dig deeper. They began cross-referencing the timing of the event with temperature fluctuation logs, solar incidence angles, and even distant impact alerts from NASA's lunar monitoring systems.